All right, test review day. Let's get to it. 7 problems. Find the critical points. Are they local min, local max, or inconclusive? Let's get right to it. Number 1, f of x is equal to x squared plus 14x plus 45. Find all the critical points. Local min, local max, or inconclusive. So what I want to do is let's just get all of our tools available. Let's take the derivative. So you got 2x. And the derivative of 14x, that's just plus 14. Okay. And the derivative of positive 45 is 0. And just for the sake of argument, let's do f double prime of x. So the derivative of 2x is just, well, 2. And the derivative of 14 is 0. So quadratics have this unique feature where the second derivative is just going to be a constant. So for the first 4 problems, I like it. I like it a lot. So now, what do? Well, step 1, after once we've labeled our velocity and our acceleration, well, f prime of x, let's set it equal to 0. So now that we've got 2x plus 14 is equal to 0, solve for x. So we're going to subtract 14 from both sides, leaving me with 2x is equal to negative 14. So far, so good. And now we're going to divide both sides of the equation by 2, leaving me with x is equal to negative 7, and that's going to be my critical point. Okay? And we're going to use the second derivative test, and I'm just going to jump right to it. Hey, in a quadratic, remember that our graph is either going to be happy face or sad face. And the second, in algebra, they teach you, hey, look at the A. The A is positive, so it's a happy face parabola. But, if you want to do this using the calculus way, notice that the second derivative is positive. So what this means is based on the second derivative test, it doesn't matter what I plug in, it's always going to be 2. That means it's going to be a lowest point because the second derivative is going to tell you that the graph is rising. The graph is rising after the critical point. So that would be a local min. And just to show you in the graph, f of x is equal to x squared plus 14x plus 45. Where is that x value that is a critical point? Negative 7 comma negative 4 is a lowest point. X equals negative 7 is a lowest point. Now, let's take a look over here. Problem number 2. Spoiler alert, a is equal to negative 1. It's a quadratic. Okay? Generally in college, you'll see these, on the test, but, with calculus language. So let's get our tools out of the way. So in order to find the critical points, I need to figure out what my f prime of x is and my f double prime of x. I love that second derivative test. All right, so let's take the derivative of f with respect to x. Derivative of negative x squared will be negative 2x. And the derivative of negative 12x will be negative 12. And the derivative of positive 3 is going to be 0. Now, let's take second derivative. So the derivative of negative 2x is going to be negative 2. And the derivative of negative 12 is a constant, that's 0. So now that we've got our first and second derivative out of the way, let's use the first derivative, set it equal to 0 so that we can solve for horizontal tangent lines. So let's go. So now that we've got negative 2x minus 12 is equal to 0, let's solve for x by adding 12 on both sides. So now I've got negative 2x is equal to positive 12. I'm going to divide both sides of the equation by negative 2, and therefore x is equal to negative 6. That is the x value of my critical point. Now, Let's look at the second derivative. Luckily, the second derivative of a quadratic, x squared, is always going to be a constant. Is the acceleration going to be positive or negative? Negative. So at x equals -6, that tangent line is horizontal, therefore making it a critical point. But since the acceleration is negative, my psychic crystal ball tells me that this graph will fall after it reaches this critical point, which tells me that that is the attribute of a local max. And just to prove it, let's take a look at the graph. Let me just delete this original graph really quick. So I'm going to put this graph up here. Let me just, it's a sad face parabola. And the highest point is at -6, positive 39. That answers the question that the critical point is at x equals -6, and that is a local maximum. Okay. All right. Moving on to problem number 3. Another quadratic. F of x is equal to 7x squared minus 42x is equal, 7x squared minus 42x minus 9. Let's solve for the critical points. Okay. So first things first, f prime of x is equal to, derivative of 7x squared would be 14x. The derivative of -42x would be -42. And the derivative of -9 is 0. Very, very happy. Now, let's do f double prime of x. F double prime of x is, okay, we've got the derivative of 14x with respect to x, that'd be 14. And the derivative of -42 is 0. Yet again, one of the beauties of quadratics is that their acceleration is constant. Fun fact for physics. So now I've gotten my tools out of the way, so let's do some algebra. Set f prime of x equal to 0, so when is the slope going to be 0? Okay. Now I'm going to solve for x by adding 42 on each side. So now I've got 14x is equal to 42. And now I'd like to divide both sides by 14. So therefore, x is equal to 42 divided by 14. That would be 3, because it goes 14, 28, and then you add 14 to that. That'd be 42. So x is equal to 3 is my critical point. And now I'm going to take a look at the second derivative, a constant in this case. Very, very happy with that. So my second derivative is 14, which tells me that at the critical point, x equals 3, it's a horizontal tangent line, but it's going to rise. My crystal ball tells me it will rise after the critical point. So if it's a horizontal tangent line and then it rises, those are the attributes of a local minimum. Okay, so let's prove it with the graph. So 7x squared plus 42x minus 9, it's green. Let's figure out where there it is. So at x equals 3, it is a local minima, specifically at 3, -72. I love technology. Okay, moving on to problem number 4 now. F of x is equal to -10x squared plus 300x minus 67. A lot of big numbers. No match for my velocity and acceleration function. Thank you, calculus. You've saved me yet again. So let's figure out what my f prime of x is and what my f double prime of x is. All right, so my f prime of x, the derivative of -10x squared, that's going to be -20x. And the derivative of positive 300x, well, as big as it is, I know that it's just positive 300x. Okay. And the derivative of -67 is just 0. Now, wait, hold on. Just make that a little bit clearer. I know it's only one mistake. -20x plus 300. So that's my f prime of x. I apologize for that. Now let's take f double prime of that of x. That'd be negative 20. And that's it, because it's very, very exciting, because the derivative of 300, as big as it is, it's still a constant. Therefore, the slope of a horizontal line is 0. So now that we've gotten these out of the way, we're going to set f prime of x, which is negative 20x plus 300, which is equal to 0. Let's start hunting for some horizontal tangent lines. So now we're going to solve for x by subtracting 300 from both sides. And now I've got negative 20x is equal to negative 300. So now I'm going to divide both sides of the equation by negative 20. So x is equal to negative 300 divided by 20. I'm going to get a calculator. I believe it's 15, but I'm just double checking. 15, yeah, because 20 goes into 100 5 times, and you triple that, it's 15. So x is equal to 15, wherever that is for y, but I care about the x value because I can graph. And I can plug it into the original amount. I just, in college, they'll ask you what's the x value, most likely. So now, I care about the second derivative. The second derivative is negative no matter what I plug in. So if the tangent line is horizontal at x equals 15, and my crystal ball, my acceleration, second derivative tells me it's going to fall, well then those are the principles of a local maximum, local max. And just to prove it, let's put it to the graph. Okay, oof, that looks like it's going to be very, very steep. I'm curious where it lands. Oof. I'm going to zoom out, and go, ooh, I got to go really high. Oh my good, oh, it's thinning out. Where is it? Let's zoom in. Okay, so my local maxima is located at x equals 15. Oof. 15, 2,183. That's a very steep y value. I'm glad I didn't plug it in. But yeah, the idea is you can figure out which x value has your critical point. Math is power, my friends. Okay, so now let's get into higher degree polynomials. So specifically, f of x is equal to x cubed minus 3x. Number 5. I want to figure out where the horizontal tangent lines are and determine whether they are local min or local max, or neither. So now, f prime of x, that's going to be 3x squared, and the derivative of negative 3x is negative 3. And now my second derivative is going to be 6x. It's not a constant, so I will need to plug in my critical point into that second derivative. Okay, now then, let's set f prime of x equal to 0. So how do I solve for x here? Well, I can factor. Always factor if you can. 3 times x squared is 3x squared. And 3 times negative 1 is negative 3. Reverse distributive property. And I'm not done factoring because this is the difference of two squares. So specifically, I can factor the difference of two squares into conjugates. X plus 1 times x minus 1 is equal to 0. And now I'm going to split this into two cases, because now I can break this up into x plus 1 is equal to 0, or x minus 1 is equal to 0. I'm going to subtract 1 from both sides. One of the critical points is located at x equals negative 1. The other critical point is x equals positive 1. Now, the second derivative test is going to tell me, does it rise or fall with my crystal ball? Okay, so now we take a look at the second derivative. F prime of x is equal to 6x. And now I'm going to plug it in for each individual value. So let's do f double prime of -1 and f double prime of +1. So my second derivative at x equals -1 is -6. So that tells me that it's going down. I'm yelling local maximum, because the tangent line is horizontal and then it has a negative slope. So that is a local max. Okay, now let's plug in x equals 1. Well, 6 times 1 is 6. So that tells me that at x equals 1, the acceleration is positive, so it's going up. So once the tangent line is horizontal and then it becomes positive again, those are the attributes of a local min. And let's check with the graph. So if I graph f of x equal to x cubed minus 3x, let me go home first because I was in the 2100s. I was not. There we go. That's more sane. That's my sanity's restored. So now I look at x equals -1 and x equals 1. It appears that x equals -1 is a local max, just like our math predicted, and x equals +1 is a local min, just like our math predicted. Math is power. All right, let's do 2 more, and then we'll call it a day. Okay? F of x is equal to x plus 8 quantity to the 9th power. Don't you forget about the chain rule. So now we've got f prime of x. Notice that I'm going to call this green. The derivative of green to the 9th power is going to be 9 green to the 8th power times green prime. I just want you guys to remember the chain rule, as simple as this binomial x plus 8 is. Let me just zoom in. So now I'm just going to clean this up a little bit. Notice that x plus 8 prime, that's just 1. So in the end, f prime of x is literally just 9 times x plus 8 to the 8th power. Okay? Well, now I want to figure out what f double prime of x is. Now, I could do product rule, but remember, if 9 is u and x plus 8 to the 8th power is going to be v, well, then u prime is going to be 0. So that first part is gone. So you basically u v prime. So my little tip is, if you have a constant in front of a big function, ignore it, and then factor, and then take the derivative. So in this case, what's the derivative of x plus 8 quantity to the 8th power? That would be 8x plus 8 to the 7th, and then x plus 8 prime. Again, if you want to show your work, but remember we factored out the 9. Okay? All it is, just easing your anxiety. Okay? So I'm going to show, sorry, I didn't mean to knock the camera. That'd be 9 times 8, which is 72. And then x plus 8 quantity to the 7th. And then that's just 1. So that's my f double prime of x. There's a lot of information, so I'm going to box the ones that I care about. So I care about f prime of x and f double prime of x. This just makes my life a little bit easier to use the simplified version of the derivative. That took a lot of work. So now let's solve for x when f prime of x is equal to 0. So f prime of x, which is 9x plus 8 quantity to the 8th power is equal to 0. I'm scared. Well, I'm going to ignore this 9 because it's never going to be equal to 0. So in this case, I care about x plus 8 becoming equal to 0. And now I'm going to solve for x. And now x is equal to -8. That's my critical point. How exciting. And then I'm going to use my second derivative, f double prime of x is equal to 72 x plus 8 quantity to the 7th power, where specifically I'm going to plug in my critical point x value, -8. So f double prime of -8 is -8 plus 8 quantity to the 7th power. Well, 72, -8 plus 8 is 0. Oh, well, that can't be good. 0 to the 7th is 0, times 72 is 0. Huh. Go back to your notes. If the critical point, if f prime of x is equal to 0 at x equals -8, which means it's horizontal, and then the acceleration is 0, that's a big load of I don't know. So it's inconclusive. The point is it's neither. I didn't fit it in the box, but you get the idea. Inconclusive. Because if I were to graph this, take a look at this. So even, oh, wait. That was like to the 9th power. Oops, not to the 4th power, to the 9th power. Look at this. Yeah, because that would have been a local minimum. I was like, that didn't make any sense. There we go. So I believe that the visual and the math should make sense because, like me, I make mistakes very, very easily. So I love to check my work. So if you pay attention, it starts to flatten out at x equals -8. After rising, it goes to x equals -8, and then it rises again. Rise, stop, rise is not a characteristic of a local minima or a local maximum. Okay? So it's inconclusive. All right, one more, and then I will share with you the exam. Number 7. -3x to the 5th plus 5x to the 3rd. All right, let's get down to business. So first things first, I want to figure out what my f prime of x is. And then I want to figure out what my f double prime of x is. Then I'll get my tools, and then I'll set f prime of x equal to 0 and solve for x. So f prime of x, -3x to the 5th, that derivative is -15x to the 4th. And the derivative of positive 5x cubed, that's going to be positive 15x squared. Oh. All right, well now let's figure out what my f double prime of x is. That's going to be -60 x to the 3rd. And the derivative of positive 15x squared, that's going to be positive 30x. Okay. I just want to see. So this one is going to be fun. So let's set f prime of x, which is -15x to the 4th plus 15x squared. And let's set that equal to 0, and let's see what we can do. So I typically don't like leading coefficients that are negative. So I'm definitely going to factor out a negative. Okay. Specifically, what can I factor out of 15 and 15? Oh, 15. So I'm going to factor out a -15. X to the 4th and x squared both have an x squared in common, so I like this piece by piece. All right, -15x squared times a positive 1, and x squared times x squared is x to the 4th. Negative times a negative needs to be a positive. 15 times 1 is 15. X squared times 1 is x squared. So that's going to be a 1. Okay. And then this is the difference of two squares, so I'm going to factor this even more into -15x squared, x plus 1, x minus 1. Don't you forget how to factor. So now I'm going to break this up into not 1, not 2, but 3 critical points. And let's see what awaits us. So specifically, you would do 15x squared, negative 15x squared is equal to 0. So x equals 0 is one of your critical points. X equals negative 1 would be another one of your critical points. And x equals positive 1 is another one of your critical points. So now we're going to plug in our second derivative critical points for all 3 of these. So now that we know that f double prime of x, I just don't want to scroll up and down all the time, negative 60 x to the third plus 30x. Okay, so the beauty of these is you don't really need, like, let's say you would get like a negative 8 and you would plug it in. It's like, do you care about the big number or do you care about whether it's positive or negative? So always look, is it positive or negative? That's the real second derivative test. So I'm going to start with f double prime of 0. So that's going to be negative 60 times 0 cubed plus 30 times, oh yeah, I see this. I see this. So 0 cubed is 0 times negative 60, who cares? And then 30 times 0 is 0, so that's going to be 0. So on the first one, really? On the first one? You give me an inconclusive one? All right. Better not do that again. All right, so now let's do f double prime. I'm going to jump to 1 because I'm feeling very positive right now. So let's go with negative 60 times 1 cubed plus 30 times 1. Then, well, 1 cubed, it's just going to be 1. 30 times 1 is also 1. So this is just negative 60 plus 30, which is negative 30. Okay? So negative 30 acceleration tells me that my psychic second derivative says it's going down. So if it has a horizontal tangent line and then it goes down, those are the characteristics of a local max. All right. Well, now let's do f double prime of negative 1. So let's plug in negative 1. Ooh, I wrote on the notebook on the O there. So let's put negative 1 right there, and let's there we go, much better. Okay, so piece by piece. That'd be negative 60. Negative 1 quantity cubed is still negative 1. And 30 times negative 1 is negative 30. So now I've got negative 60 times negative 1, that's positive 60, minus 30. And that's going to get me a second derivative of positive 30. So my positive acceleration tells me at my critical point, it's about to go up. It's going up. So if it's going up, those are the principles of a local min. So just to reiterate, I'm going to get some weird rise, stop, rise, or fall, stop, fall at x equals 0. I'm going to get a local min at x equals negative 1 and a local max at x equals positive 1. So this is the graph. Yeah. So at x equals negative 1, local min, just like our math predicted. Rise, flatten out, rise again. I don't like that, so it's inconclusive. I have no idea what's going on. Well, I do. I'm just playing along. I'm just playing a character. But it's neither a local min nor a local max. And then at x equals positive 1, we have a local max. So local min at x equals negative 1, inconclusive at x equals 0, and a local max at x equals 1. All right. It's been a pleasure to teach you critical points. Hopefully I was clear in these lessons. So you will get a test soon. Good luck.